Easy may not be a word that comes to mind for designing clean room environments. However, by tackling issues in a logical sequence, you can produce a solid cleanroom design. This lecture covers each key step and specific tips for adjusting load calculations, planning filtration paths, and mechanical room space relative to the cleanroom class. This is part of multi-lecture series designed by Technology Education and Mentoring Center on the topic of clean rooms for industry. Various steps to be followed while designing a clean room are enlisted in the slide. It is important to note that first step is to determine the layout for material flow and movement of individuals. Cleanliness class determines the airflow rate and ventilation features. Designing clean rooms for different industrial applications require separate calculations in relation to airspace balance and heating or cooling equipment. These two aspects ultimately determine the cost of the project. Mechanical equipment and its layout is an important step in designing clean room. In preceding slides, each of the 9 steps design guide is explained in detail. It is important to evaluate people and material flow within the cleanroom. Some pharmaceutical and biopharmaceutical processes are susceptible to cross-contamination from other pharmaceutical and biopharmaceutical processes. This needs to be incorporated while designing the layout. The Institute of Environmental Science and Technology, IEST, Standard 14644-1 provides different cleanliness classifications and the allowable number of particles with different particle sizes. It is very difficult to consistently maintain cleanliness classification in designated space, when it has neutral or negative space pressurization. Hence, positive pressure must be maintained. The recommended maximum pressure differential across a door is 0.1-inch water gauge. At this pressure, a 3-foot by 7-foot door requires 11 pounds of force to open and close. Space cleanliness classification is the primary variable in determining a cleanroom airflow supply. Cleanroom air change rate should take the anticipated activity within the cleanroom into account. IEST has published recommended air change rates in Standard 14644-4. It is important to understand that clean rooms are not hermetically sealed and do have leakage. The amount of air exfiltrating through doors is dependent upon the door size, the pressure differential across the door, and how well the door is sealed through use of gaskets, door drops and closure. Ideally, a clean room should not have more than 2% volume leakage rate. The air balance is sum of inlet and outlet of air supplied through ventilation system. It is determined by balancing cleanroom supply, infiltration, exfiltration, exhaust, and return airflows. Due to high airflow in clean rooms, a large electrostatic charge is developed. When the ceiling and walls have a high electrostatic charge and space has a low relative humidity, airborne particulate will attach to the surface. It is important to keep the relative humidity high enough to reduce the electrostatic charge buildup. Relative humidity of 45% is considered to be satisfactory, as cleanroom workers wear smocks or full bunny suits over their regular clothes to reduce particulate generation and potential contamination. Hence, comfortable environment parameters should be maintained. Comfortable temperature of room is 22 degrees Celsius. Noise and vibration levels should also be kept to minimum. Unlike normal air conditioning systems, cleanroom have substantially more air supply than needed to meet cooling and heating loads. All the important parameters flashed on screen must be kept in mind while designing mechanical system layout. Available funding decides the quality of equipment to be installed and energy cost determines the operational budget. Heating and cooling calculations must be carried out with extra care. If calculations are made on conservative side, the cleanroom will be able to function without delays that are mostly caused due to improper environmental condition. Humidifiers must also be selected after proper analyses. Cleanrooms are like race cars. Cleanrooms have many potential pitfalls. Hence, proper design and engineering team should be assigned the job of finalizing the intricate details of the envisaged cleanroom. Other lectures by TE&MC on cleanrooms describe cleanroom classes and basics of building cleanrooms for industrial research and production. Links related to Technology Education and Mentoring Center are flashed on the screen.